Hello everyone and welcome back. If you don't know me, I'm Ruslan Brilenkov, a senior data scientist working here in Canada, and on my channel I talk about the data science, technology, artificial intelligence, as well as my experience of immigrating and life in Canada. Today we are going to talk about relational databases, where relationships aren't just for people, but for data too. Why should you care, you may ask? Well, because understanding things like primary and foreign keys are the essential part of relational databases, and it's a secret sauce to keep your data well organized and searchable, and more importantly, not a hot mess. For this, let's build a real life but simplified example of a library. To build this database, we will be using PostgreSQL with the PGAdmin 4 graphical user interface, as you can see on my screen right now. Here we are in the PGAdmin 4. You might not have any running servers as of yet. Then you can just create a new server by clicking a quick link, add a new server, or press right click, register server, give it a name, library, DB, server, or whatever you would like, connect right away. As for the connection, you can use a local host, which is your local machine. Standard port for PostgreSQL is 5432. This port that PGAdmin 4 uses by default, 5432, doesn't matter that much right now, but then we will get to the point of placing your Postgres in a Docker container and in the future videos, and you will see how these ports help us to connect to this database instance there. When you downloaded the PostgreSQL and PGAdmin 4, you had to set up your password. In this case, I have this password saved, so I will type my password. You can type password you have and keep all of the other parameters the same. Save. It should create connection to your local database. As you can see, I'm already connected essentially to the same database, but it doesn't matter much because we will build everything from scratch right away. So I will delete this server by clicking remove server, delete, and go here in this server. I can type somewhere here on query tool. Now let us build our library database. Why do people go to the library? To borrow books, right? Each book has an author, right? So we will need to create at least two tables, which we will call authors and books. So let's do it. We will use syntax create tables authors. We'll have a couple of columns, make it serial, primary key, our ID, and we will give it a name, variable character of 50 symbols as 4, which is not null because we don't want our author entity to be empty, right? And create table books also with their own ID, again serial, primary key, and for this let's have the title character maybe 200 symbol. The books can have longer titles in principle, right? And if we leave it as it is, we will have essentially two independent tables. Table authors with its own primary key and a name column, and table books with its own primary key, which is ID of the book and title. In order to link these two together, let's create a foreign key. It is a key that will link to a primary key of another table and will be integer references, which tables authors and which column in a table authors, column ID. So this gives author ID capacity to link to the primary key of table authors. You can see for naming primary key, foreign key. The principle of naming foreign keys for the ease of usage is to make sure that you have a table that you want to refer and its own primary key, like this table, foreign table underscore foreign key. It will be really easy to link these two together. Let's run it and see that it created tables successfully. We can also refresh it and see that we have authors and books. Make sure that there are no errors when we rerun this code by placing if not exists. Now we want to insert a couple of values here. Insert into authors. Since our primary key is serial type, we don't need to insert ID and name. We can just use name, then insert values, which Jane Austen, next George Orwell, J.K. Rowling, and for the table books, we want to insert a couple of books. I will copy them. Okay. We want to make sure that we have our author's ID, our foreign keys, which will correspond to each author. Now let's see that we have this data insert error, column name books does not exist. Oh, it's a title. Sorry about that. Insert or update on table books violates foreign key constraints. Okay, it's not present in table authors. Let's see what is present in table authors right now. Somehow our query didn't run and didn't insert them. There was an error apparently. Let's change it by hand right now. Later on I will show you how to change data programmatically and how to make sure that these kind of hiccups don't happen. You can see that one part of the query did run well and inserted the data here, but another part failed. So we essentially wrote data partially, right? In order to prevent this from happening, there are concepts called Atomicity. Essentially, it will ensure that all of these transactions happen in one transaction block. If something fails, everything is being rolled back. For now, let's quickly insert our books once again. What happens? Relational already exists. Insert or update table books violate. Why would it violate? Author's ID equal 1 is not present in table auths. I think it was present there. Oh, I was talking about this and updated them, but it didn't say it. While I was talking, that's why it made this error. There was no primary key 1, 2, 3. Actually, quite a smart system. What did I want to do here? I wanted to make sure that these are also sequential numbers starting from first value. And now we don't want to insert any more values because it will apparently keep updating this sequence, right? Now we see that we have our table books. Next, I want to show you how we can query these tables, books and authors in combination to connect each title of the book with its corresponding author. For this, let's select from books. We want to select title of the book, inner join, can write even BKS, alias referring to this table books. We will select table authors, BKS title, as well as authors, author.name. These are the two tables we'll select, and then authors as author, and we are joining on which key. This is the most important part of this tutorial. We are joining on the primary key from author on the ID, which is equal to the foreign key from table books. Now we should be able to see the combination of tables, book title and author name. Essentially, that's the basic principle of how we can create and link these primary foreign keys. There are a couple of things we can do. For example, do some analysis, right? Let's see how many books each author has. In this example, we have only 3 authors and we can count them by hand, but in real data we will have 50 different tables, so the relationships or the analysis is not as clear cut, right? And group by author name and then count distinct order by book count, ascending order to see first of all authors with the lowest number of books. 1 book was Harry Potter, and then George Orwell 2 books, Jane Austen 2 books. Even with this, we already can start building up some data analysis examples. books. That's what I also do on my job as some part of my responsibilities, analyzing these kind of things. But query I write in a day, I can write 200, 300 lines of code, since I want to make sure that my work is reproducible by anyone else, and then it is compliant with all of the regulations. Because right now I am working as a senior data scientist in one of the leading insurance companies in Canada called Definity. I'm dealing with huge databases, and there are so many connections. It's not as simple as one-to-one connection between two tables, which actually brings me to the next section, which is many-to-many connections. Honestly, if our library only has a collection of books and no customers to read or borrow those books, the library will be quite boring, right? For this, let's create a table called borrowers, ID, serial, primary key, borrower name. Again, 50 characters, and not now. And now I will explain this right away, because it's even more important concept than just creating a primary foreign key pairs. When we have one book, which can be borrowed by multiple people. One person borrows, for example, Harry Potter and Philosopher's Stone, and 2 weeks later that person brings it back to the library. Then the next person can borrow that book, and so on. So we will have one book corresponding to many borrowers, but also each borrower can borrow multiple books, right? So we cannot simply link tables, borrowers, and books as it was between authors and books. In this case, we have many relationships. So in order to handle this, there is important concept which is called a junction table, also called linking table or associative table. It connects by storing record of each time a borrower borrows a book. It creates this connection inside this middleman junction table. It will allow us to track which borrower has borrowed which book and when. To do this, we will need to create table loans, again ID, serial, and then most importantly, several foreign keys that will link to each of those primary keys. Book ID and borrower's ID. Link to borrowers, and books will lead to books. Timestamp when borrower took the book, and let's call it a date timestamp. And now let's run this linear create table. I forgot to close this query. All right. What can we do? Let's take this table. Trying to think how to make this a bit faster, but as I'm explaining everything already, let's go step by step. Let's say John Doe, maybe Mary, Jane Q, public, some really imaginary name, Superman. Even Superman might be visiting a library, right? It's Mickey Mouse from our previous video, right? So now, as for the borrowers, insert serial ID will be populated on its own. We want to have book ID, borrower ID, and loan date. There are ways to do this automatically when using, for example, stored procedures and trigger functions, as I explained in one of my previous videos. In this case, so let me make this after all date to make it easier. For example, let's say that borrower ID was what John Doe borrowed a book, for example, Pride and Prejudice, which had ID 1 and then 2, 3, 4, and then, for example, Animal Farm, ID 1 and 4. ID 1 and let's say ID 4. John Doe borrowed Pride and Prejudice on which date? It was, for example, a week ago from August 11. It means it's August 4, 04, 08, 25. We can also write it the other way around. Very simple. And then the same person borrowed a book today. Mary, which will have the ID 2 in this case. She borrowed a book yesterday, 1984. It will be book with ID 3, right? 1, 2, 3, yeah. And then let's say someone borrowed it on July 1st. Superman and Mickey Mouse are not that illiterate. They don't visit our library, so we will not let them borrow any books. But now I want to insert the data one by one, just to see if this worked. All right, as you can see, our table borrowers is complete. We don't need to insert any more values here, but we want to insert in the loans. I'm really interested if this would work, because usually writing these things by hand is prone to many errors. So usually, as I mentioned, you have different stored procedures, functions, and automated scripts. But now let's see if we got, yes, nice, all of the information correct here. Essentially, we are interested in this date. So now our junction table, which is really the most important connecting piece. And now I want to see, for example, who borrowed which book and when. You can see that we are joining this junction table loans, inner join by default. So we want to connect borrowers by their primary key ID with the loans book ID as the foreign key with the primary key of the table books. You can see, as I explained, when you call foreign keys by the name of the table and the name of the ID, it's really easy to connect them. Again, we will order by borrower name in ascending order and loan date in ascending order. Here we have our John Doe, who borrowed the books on August 4 for Pride and Prejudice, and then August 11, Animal Farm, as well as JNQ Public and Mary. Now, if I want to show you something else, what you can do here, inner join, and see when someone borrowed a book 1984. For example, a real case scenario, if we found out that the book with the title 1984 was all torrent, and someone would inefficient wrapping in the paper of the book, horrible book maintenance. We want to know who is potentially bad actor and bad borrower, who should be a bit more careful before lending any more books. And in this case, you can see, unfortunately, it was example of Mary. No offense, just imaginary name, but we want to hunt down every borrower like that. In a way, we could do something similar if you think about the insurance. There are apparently a lot of fraud going on, and there are some common cases of customers trying to trick the system and do some shady business, which is very dishonest. It would be so much better if they would put all of that energy into something positive. That aside, this is an example of how we can do simple analysis from having many relationships. I hope you enjoy this video. I try to explain it really step by step of building this database from the first principles, and also sharing some of my examples from work I'm doing right now. And here you have it. With just a few tables and a couple of clever relationships, you can really organize your data like a pro. If you found this helpful, don't forget to subscribe, hit the like button, and share with others if you think it was helpful and you enjoyed it. Leave me a comment if you would like to see more of such examples of how I build things step by step. As someone pointed out comments on one of my previous videos today, we would like to see more hands-on examples. I think it's a valid point, but also it takes more time, and not everyone has so much time to look at all of this information. But if you enjoyed it or you have any more recommendations, please leave me a comment. As I keep saying all the time, I want to be a two-way process and make this channel as interactive as I can, and not only speaking monologue from my side. In the next video, I'm going to show you how we can create a Docker container instance, put our database there, and I will explain in more details why you would want to do that and why I would recommend everyone doing that, even if you are working locally. That's it. See you next time.